All right, so this is a presentation that Eric Frappa recently published a message on IOTA occultations because we had exchanged some messages on this, but it's certainly worth another presentation here, although I think Eric's message is totally complete and to the point. My point is, never use 3 DNR camera setting, ever. Don't ever use it. Okay, so there are many CCD video cameras that are NTSC or PAL format that have a setting called 3 DNR. And the short list that I have is the Watt 910 HX RC and the BD, but not a lot of us here in the US use the BD version. The Malin Cam has it. A lot of people in recon use Malin Cams and other people around the US. There was the older PC-165 DNR. Notice it even has a DNR in its title. And then our newest one, the RunCam Night Eagle Astro Edition, that's the one for sale on the IOTA website. That has a 3 DNR setting. So there are lots of cameras that are in use with that setting. So what we're going to talk about today is an important thing for our general membership to be aware of. Now, how 3 DNR improves video noise reduction. I clipped this off of the internet. The next four slides are excerpted from an article posted in the website Security Cameras. So they invented 3 DNR because the chip inside the camera is constantly picking up noise, creates its own noise, and that noise, the artifacts can translate into the images in the video as a fine static or snow or fuzzy images. It looks like random noise in the background. And so they invented digital noise reduction, and that's a method by which the camera's imager digitally removes noise from the image. And 3 DNR is an advancement of that technology and filters noise even more and in low light conditions. So the traditional DNR is uses a temporal noise reduction. So the technique basically compares one frame to the next and removes tiny specks in each frame that do not match up. And the idea is that you can blend frames together and then reduce the overall noise content. And generally, the traditional DNR only removes the noise and unwanted data found in the front of the scene, meaning the brighter parts of the scene. And that the object in the background are processed to reduce the visual noise, and anything in the background remains unprocessed. Part of the problem is that our videos are faint stars, and so that stuff appears in the background and it can be effective. So there was an example of a parking lot at night business, and I'll show that picture here. This would be without 3D DNR, 3 DNR, and this is with 3 DNR. And you say, wow, that really looks great. Why wouldn't we use that? You know, it really improves the video. Okay, well, we'll talk more about that. So what's different about 3 DNR? It takes that traditional DNR a step further. Not only does 3 DNR handle the traditional frame-to-frame noise, but it also incorporates spatial noise reduction. And spatial noise reduction compares a pixel with its neighboring pixels to detect and remove unwanted noise found within the frame. And then it processes the entire image to remove digital artifacts and grainy appearances while trying to maintain image clarity and sharpness. 3DNR is particularly troublesome for occultation astronomy. This is the part that I've added. It doesn't come from that website. Because it affects faint stars over many frames, trying to keep them from fluctuating too drastically. For an occultation, this has the effect of applying a running average type of adjustment to faint stars, which causes the DNR events to be gradual rather than instantaneous. So here is a normal occultation light curve without 3DNR. It's on a Watt 910 HX camera that was taken by Paul Maley on the 670 IOTA Mtg. I don't know how to pronounce that. Occultation. Looks pretty normal noise. Nice straight disappearance, reappearance. Good light curve. Paul's really perfected his craft. And here is an occultation light curve with 3DNR. This was taken by Paul Maley for the Varda occultation, which was a Lucky Star event, 2018 9/10. And you'll notice that there are lots of gradual ups and downs in the light curve. These are secondary stars. This is probably the tracking star, tracking star 1. And the blue is tracking star 2. And notice that there are various ramps in the brightness increases in these secondary stars. And then if we look at the target star, which is the red graphic, we found the same thing, that the star disappeared gradually, got to a bottom. Everything is kind of gradual, up and down, up and down. So in the Varda occultation, it was a TNO observation that was made as part of the Lucky Star project. And Paul's observation was problematic as it caused the DNR to appear as gradual events. And researchers in the Lucky Star project thought that it might be evidence of an atmosphere around Varda. So they were like excited. Oh boy, we got an atmosphere. So Paul and I were looking at his video because they contacted him and said, gee, you might have an atmosphere. And Paul and I reviewed his videos, and we weren't quite sure. We thought that the fades were an artifact of the capture process. Paul had recently changed his capture hardware to a new FireWire capture card, and we thought that that was what was causing the gradual changes. We did a lot of research. We told the Lucky Star folks, no, those gradual changes are artifacts. They're not real. It's not an atmosphere. But Dr. Bruno Siccardi and Dr. Felipe Braga-Ribas and Dr. Damya Suami spent a lot of effort researching what might have caused the gradual DNR, if not an atmosphere, because they were going to write a technical paper, publish it. It's about to be, it's been accepted. It's going to be published. And they wanted to explain why this light curve with gradual changes wasn't an atmosphere, if in fact it wasn't. So they communicated with Eric Frappa. He's the European coordinator for IOTA. And he had seen similar behavior in other videos, and he traced it to 3DNR. And here's an excerpt of his explanation. And it says, I have been able to reproduce exactly the same behavior in Paul's video using a 3 DNR filter set to on at 50% level. And that's the default setting of the 910HX. So he was using a 910HX and testing it. So what he did was he applied abrupt moves to the telescope to make the star jerk to a different position. So in applying abrupt corrections with the hand controller on the star field centering, duplicated images of the faint stars appear when there's no duplicated images for the bright stars. So what 3DNR was doing was it was tracking bright stars, making them look fine, but the faint stars, it was creating ghost images that would gradually fade away and gradually brighten. So these ghost images of the faint stars located at the position before the correction fade gradually and disappear, when at the same time the images of the faint stars at the new position, where he just moved the telescope, brighten to the normal value, but they do it gradually. The same test shows no anomaly when performed with 3 DNR filters set to off. Now, Eric recently posted a message on IOTA occultations that it takes this and gives a full explanation of the entire process. I recommend everyone read it. It's under the subject, Watec 910 HXVD users beware of 3 DNR filter, and it was published on July 23rd. So, at the same time, I serendipitously confirmed this diagnosis that Eric came up with independently. So after the research was performed by Lucky Star and the IOTA and Eric Frappa, I accidentally observed the same problem with several of my observations. So I recently moved to a new home here in Scottsdale, and many of my observations have been made on very hot evenings. It gets a little warm down here sometimes. And when I look to the southeast or east, I look directly over the roof of my home. So the resulting light curves were all very wavy, and the DNR transitions were gradual. And I'm showing the Adelinda report that I had talked about previously. So here's multiple target, here's the target star here in blue. This is a field star, tracking star, and a comparison star. And I mentioned before that this little drop over here corresponded to some sort of a cloud effect. But over here was my event, and the event was very, very gradual, up and down. And that was the one I said, well, I don't trust that. I don't think it's a real event. Well, I've now found out that since I knew the Varda occultation could cause gradual events if your 3 DNR was turned on, I checked my Watt 910HX camera, and darn if it wasn't set with 3 DNR on. And I didn't do it. So it turns out that anytime you reset the Watt 910HX, and I know I did that because I wanted to reset my bright pixel correction because it gets a little hot down here and I get a lot of hot pixels. I did reset my camera. It automatically reverts to 3 DNR on at the 50% level. So it turns out in retrospect that it would have been easy for both Paul and I to accidentally reset our cameras, as the reset menu is also very close to the exit menu on the camera, and you never know what people do in the dark. So the moral to this story is never use 3 DNR setting on your camera if you have that feature. If you use a Watt 910 HX or RC or BD camera, be sure and change 3 DNR to off if you ever perform a reset. And Eric recommends check your Watt 910 HX camera occasionally. He says all the time, every observation, in case you might have inadvertently reset the camera and turned 3 DNR back on. So I'd like to thank Paul Maley on this one because he is the one that contributed some critical light curves. And then the Lucky Star authors for their persistent pursuit of the cause of the gradual DNR and the Bartok occultation, because if they hadn't have persisted, which as the good researchers that they are, they did, I would have never found this on my camera. I'd still be recording today thinking I had 3 DNR off. And then thanks to Eric Frappa for his insight. And it was because he's seen it in other European observations and figured it out. So it was a real team effort. I wanted to thank everybody for that. And Roger, I'll kick it back to you.
Okay, well, thank you very much for that, Tony. That's very interesting and reminds us to check the settings on the Watec 910 HX each time we use it. Okay.